I wanted to do just a quick recap of everything you've already learned from Chapter 6. I want to commend all my teachers out there. You guys did a great job. I guess really, at the end of the day, everybody had been a teacher at some point, so everybody did great. I just want to put everything together into one big picture so that you can kind of see how it all fits together. So that's what I want to do right now. Okay, Chapter 6, all about confidence intervals for the population. And sometimes it was about confidence interval for the population mean, and sometimes it was about confidence interval for the population proportion. So it just depended on what type of survey was conducted or what type of experiment was conducted that told you whether or not you were doing a confidence interval for the population mean or proportion. Now, as you remember, from section 6.1, 6.2, and 6.3, we had 3 formulas for finding the margin of error. Your job in this chapter is going to be determining, first of all, whether or not you are finding a confidence interval for the mean or the proportion. And it will tell you. That's how you'll determine. So as you read the problem, you're going to be looking for your keywords, mean, confidence interval for the mean, or the keyword proportion. That will tell you which formula you need. We only have one formula for finding the margin of error. Remember, a margin of error tells you how far off your sample data might be from the population. Remember, if you're studying a group and you don't get data from every member of the group and you only take a sample, your data is not perfect. So what you're doing is you're first figuring out what's your error, how far off might you be, and then you adjust where the population might fall. So we only had one formula for finding the margin of error for a proportion, and it started with that Z critical value, and then you had P with a little caret over it. We call that P hat, Q hat. So P is the proportion that came about from your sample. Q is the complement of P. And you divide that by N, your sample size. All of that entire fraction is within that square root symbol. So that's your formula for the error if you're dealing with a proportion. Now, if your problem was talking about finding a confidence interval for the mean, well, you had 2 formulas for that. So one of them was using those Z critical values, so finding that particular value, times the standard deviation, divided by the square root of N, your sample size. That was one of your formulas. That was actually section 6.1. In fact, I should point out this down here, the proportion one was section 6.3. You also had a formula that was using that little T chart, the T distribution chart. So you found a T critical value using, again, that special chart, times standard deviation. Now remember, we have different symbols for standard deviation. This one is actually the population standard deviation symbol. This is the sample one, but they both mean standard deviation. And this one just uses that sample because they're saying if your sample size is large enough, then your standard deviation for your sample is probably really close to the population one. So they allow you to use that as a substitute. Those are your 2 formulas. The second one was section 6.2. So if your notes were based on section, then that's where it came from. You have rules for when to use these formulas. You're going to have to just memorize the rule. I use the fact that this one has a big capital Z. Big Daddy Z is my little nickname for it. So the large capital Z in the formula helps you remember that this is what you use when you have a large sample size, which traditional statistics defines as 30 or more. So if you have a sample size of 30 or more, then you're going to use that Z formula to find your error. If you have less than 30, if you only have 25 or 16 or 12 or 8, then you're going to use this formula that has a small little letter T for its critical value. All right, so capital letter Z, you're going to use the large survey size formula. Small letter T, you're going to use the small formula. That's half the battle, really, is knowing what formula for error to use. Now, I have example. I mean, there's lots of examples. This is a concept that is very prevalent in the news, very prevalent in research. It's something you're going to see if you're looking for it and if you're watching for it. You'll see the phrase margin of error very, very often. And you'll even, if you're reading research articles, you'll even see the phrase confidence interval quite often. So what I want to do is show you an article right now. And not only, you know, just the fact that they mention confidence interval, but also it's an important thing to be able to understand, especially when you're reading about research. So I'm going to pull that article up. And this is Autism Awareness Month. This is April. So this is an article about a research study about autism and some of its possible causes. So let's see. I got to pull that article up. Okay, so the article is in, in slide number 2. In fact, I'm going to post the article in its entirety on Blackboard. So if you're interested in reading the entire article, which I really recommend, it will be posted there. What I really want to highlight, first of all, let me summarize. So it's the basis of the story is that they found out that the environment of when a baby is being formed in the womb, growing, the environment might be more influential than just genetics alone. You know, previously they thought genetics was really the main thing having to cause autism, but they're that's my email noise, is a rattlesnake. Please don't be alarmed. Okay, anyway, but the point of the article is they did some research on various, in fact, here's the number, 192 pairs of twins, and they wanted to come up with a proportion for what percent or what proportion they think was caused by genetics and what they think was caused by the environment. Maybe a medication the mom was taking, the age of the mother, something like that. What I'm going to do is scroll down to the part of the article that I really want to point out to you, which is right here. Okay, so basically they're pointing out that yes, this statistical study, this scientific study, and statistics seem very powerful, but as you can see right here, the statistics have a wide confidence interval, or a range of uncertainty. And it shows here what it was. The confidence interval was from 9% to 81%. What that means is that somebody did, the researcher, did the exact same thing you're doing in class. It took the data, he or she took the data, found the margin of error using the exact same formulas you're using in class, added and subtracted it from the sample data, and that's the confidence interval they came up with. And the point of this paragraph is saying, okay, your research may seem very impressive and it may seem like it discovered something, but the fact that the proportion of the entire population lies somewhere between 9 and 81, well, that's not really conclusive. I mean, that bracket is so wide that it really doesn't really show anything. So being able to understand what a confidence interval is, how to use it, is important. And again, this is something that's out there. If you are going into science or education or even retail or business, everybody uses confidence intervals. It's important that you can understand them. It's even going to be important that you can compute it. So that's what I wanted to point that out. And I'm going to carry on with a couple examples here. And the last example that I want to point out, I've just kind of summarized for you all three of your formulas for finding the error. You have the formula for finding the confidence interval of the mean when it's a large sample size. You have the formula for finding the margin of error. I think I said confidence interval for that, but I meant margin of error. E stands for margin of error. If your sample size is small, and then this is your formula if you're dealing with a proportion. So again, this one is if your sample size, if you have 30 or more in your sample size, you're going to use the large sample formula. If you have less than 30, you're going to use the small sample. Keep in mind, these are both when you want the confidence interval for the population mean. I'm going to put pop mean. This is the only one that the only formula you need if you're finding the formula for the confidence interval for the population proportion. That's what you're doing. And then we're going to divide this into two sections just like we did in the beginning. You have problems where you're dealing with mean, problems where you're dealing with proportion. The only other thing that you have to know or really pay attention to is to get your final answer. You're going to start X bar, stands for sample mean. You find the mean of your sample. They will give it to you in the data. You're going to subtract the margin of error from that, and that's going to give you your low number. You're going to add the error from that sample mean, and that's going to give you your high value. If you're working with a proportion, there will be no mean and there'll be no standard deviation. What you're going to use is P, the proportion. So whatever your proportion is in the problem, that's what you start with, and then you subtract the error, and that gives you your small value. And then you add the error, and that gives you your large value. So that's the only other thing you need to know about Chapter 6 is that if they say find the confidence interval for the population mean, rattlesnake, you're going to use that formula. You're going to start with the mean and then add and subtract error from it. If it's a proportion problem, you start with the proportion and you add and subtract error. That's it.